Morning.
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 Good morning.
Hey Tyler, your email that you sent the other day completely fell off my radar. I'm sorry about that.
It's all good.
Um, you want to hang out after class today and we can talk about those things, or I could give you a call. Either way.
Yeah, I'll hang out after class. Um, I wanted to switch my major to massage therapy, actually. I'm just kidding. I'm really just kidding. But
Oh, that could be beneficial for the whole department.
no, it couldn't.
Do that.
No, it couldn't. Oh God, no, I'm just joking. I want to talk to you about trying to moving into like the engineering aspect whenever you know what I mean?
Okay.
I've been trying to like build these guitar pedals and like looking at like like amp schematics and stuff like that. So it kind of like helped me apply like the stuff I learned in DC and AC a little bit more, honestly.
Mm-hmm.
So yeah, that's really it. Like I kind of want to. I'm thinking about going that, but like uh, maybe like a couple classes in next semester or something like that that were like engineering like geared, I guess, like, and then see what I think about it. Or I don't know how that works, but
Okay. We'll talk.
about it later. Yeah, not a big deal.
Zach, I completely could not get that thing working the right way. I don't know. Well, I got my motor going, but I don't think I couldn't get my red push button to work, and I'm trying to see what I did wrong. I'm not seeing it.
Okay. My plan for today is first thing we'll go over homework that is due in 2 minutes. So you guys got it done. And after that, then I'm going to walk through that lab on my trainer, and
Okay.
hopefully we can catch any mistakes.
Okay.
Yeah, that's awesome because I tried to clean up my wiring and I immediately regretted it because now I'm just gonna do the whole thing all over again.
Yeah, so this is where this lab 7 is kind of where the rubber meets the road as far as understanding relays and motor starters. It's all, I mean, yeah, we'll get into it, but we'll give it a couple more minutes here and then see if Nick wants to join us, and then we'll go over the homework.
Good.
Got a question. The homework was talking about limit switches,
Mm-hmm.
and I just was looking at ours. Where do you hook wires up to on ours?
You got to open up the cover.
Okay, that's what I figured,
Yeah.
which is kind of a pain, but oh well.
Yeah. I hadn't gone over that yet because we hadn't gotten to those in the labs, but yeah, anytime
Right,
you guys, so like, this is almost like a 2-part class, and I cover the things that, like in the book work, kind of as we go, but it won't exactly be at the same pace because to me, the book work kind of supplements what you do hands-on. At least that's in my experience. That's how I learn the most is
Yeah.
actually doing the stuff and seeing how it works and putting my meter on it. And
Yeah.
but yeah,
That's why I took the limit switch apart when I was doing the homework.
yeah, good for you. I mean, that's awesome. There's nothing wrong with playing around with it. And once you take that cover off, then you can, put your meter on there and see how the contacts make and break when you activate the switch. And
Yeah.
cool. I'm glad you're doing that. There he is. It's the Nick Pedinger morning scowl.
Good morning. It's not a scowl. How's it going?
Good. Today we're gonna go over the homework first thing, and then I'm gonna walk through on my trainer Lab 7. And people are having some trouble with it, so. And that's all today.
All right.
Should be a slight
I've been
bit.
having trouble uploading mine, but I got one up, and I'll have the rest up here soon.
Okay. There's no due dates on these labs. It's just, the more you can stay on pace with them, the better off you're going to be instead of trying to cram them all in at the end of the semester. And it seems like everybody's doing that okay. So
I just 3 days on and then 1 day off and then 3 more days on. It's getting kind of rough.
yeah, you need a new job.
I do. I can't wait.
All right.
This one. There we go.
We had chapters 4 and 5, correct?
Yes.
Hey, Justin,
Yes, sir.
I'm going to come over to your place and I'm going to change the battery in that smoke detector.
I don't even notice it.
You don't
Yeah.
notice it? Like you're just used to it?
It could be that. I don't know.
Oh,
So what's the deal with smoke detectors? They can be wired up, but then the battery dies and they still beep even though they've got regular 2 or 120 hooked up to them. What's the purpose there?
Okay, so newest code says that at least on new construction, you have to have permanent 120 volt power to your smokes.
Okay.
And most, if not all of them, have battery backup anyway. But even the add-on ones that are just battery, after a certain amount of time when you're supposed to change the battery, I don't know what it is, a year or something like that,
Yeah.
it'll start chirping.
Mm-hmm.
So it's still working. It's just letting you know, hey, it's time to change the battery.
So it seems kind of dumb to me since it always has power to it, but I guess the backup power and
That's the whole
makes
point.
sense, but annoying.
So in the rare event that you get a storm and your house catches on fire at the same time,
Yeah.
it'll still wake you up.
Yeah. Well, at this point, the beeping wakes me up when it does beep. So
Yep. Okay, what am I doing? You can see my Blackboard screen, right?
yep.
A push button assembly can have multiple contact sets.
True.
True.
Emergency stop push buttons must be of the maintained contact type.
True.
True.
Limit switches are usually actuated by hand.
False.
False.
And this is another thing too, that like, I know we haven't covered limit switches yet, but if you have a question on any of this stuff, like bring it up while we're doing homework, because otherwise I'm just assuming that everybody's, got this stuff under wraps. Never directly operate a motor with a proc sensor.
True.
Why?
I forgot what it said in the book. I just remember finding it.
Yeah, I did not find it in the book. I just kind of guessed. I don't even remember what I put. So
Well,
they're not robust. They're not robust enough to handle the amperage.
that's a good way to put it. It's kind of like, why are you using a motor starter anyway? All you have to do is energize that coil to turn it on. But yeah, proc sensors usually have some small, like solid state electronic components in it, just like the one on your trainer. It's not built to handle a bunch of load. So you don't want to put that thing in series with a motor that might be drawing 10, 15 amps. Does that make sense?
I got you.
So you want to use a motor starter or whatever. Which
So
of the
then if you're using a proc sensor, then you would go from proc sensor to motor starter to motor. Would that be the correct way?
Yeah, and we're going to do that in the labs.
Cool.
Which of the following would be classified as a pilot control device?
Pressure switch.
Pressure switch. What is this picture?
I got all those wrong. I thought I knew what was going on, but
Single pole, double throw.
Single pole, double throw.
okay.
What kind of push button makes a circuit when it's pressed and returns to the open position when the button is released?
Normally open.
Normally open. Is that momentary or maintained?
That would be momentary.
Momentary. Which of the following would be classified as a mechanically operated switch?
I got this one wrong, and I put
Limit
push
switch.
button.
Limit switch.
Limit switch.
How is a push button not mechanically operated?
Because it requires a human to push it.
To push it.
Which is a mechanical action, right?
No.
But I'm not a
Not done
Same with the drum switch. I mean, they're all mechanical devices, but they're not mechanically operated. They're
The one that
human
clued me in
operated.
is that it said most of the time limit switches are actuated by camshafts, so that made it pretty obvious that that was mechanical.
Right. A limit switch is going to be activated by something that ain't me. The other ones, I don't know what a joystick controller is. That might have been like a joke that I put in there like 5 years ago, but drum switch and a push button switch, they both require me to activate them. Limit switch does not.
the joystick controllers. They're four like micro switches that you rotate and they sit inside the controller. So it's like move it around. So and it moves it in different directions. So when you activate two switches, it'll move it forward and to the left. If you activate one switch, it'll go forward, kind of like that.
I see what you're saying.
We had them on the mules in at KK. So when they moved the transmissions around, we had to repair them. Okay.
When a metal object enters the high frequency field of an inductive proximity sensor, it causes which one?
A decrease.
Decrease of energy in the oscillator circuit. And though I'm pretty sure the ones that I bought for your trainers are inductive, so they have to be operated with something ferrous, metallic. Which of the following sensors is designed to sense the strength of a magnetic field?
Hall effect.
That's Hall effect. Which of the following converts rotational speed into an analog voltage signal?
Tachometer.
Tach, just like in your car, right?
Right.
Which of the following flow meters operates by measuring the changes of induced voltage of a conductive field?
Magnetic.
What type of relay contact is that?
Double pole, single throw.
I think I've said this before, but anytime you see a dotted line on a component, like on a print, what does that mean?
Means they're joined.
It means they're mechanically connected. Yes.
Joined. Yeah.
So you can't close one without closing the other. The coil current for AC solenoids is primarily limited by
Inductive reactance.
See, you guys take 133 AC circuits, and you're like, why do I need to know this inductive reactance crap? Well, that's why. If I put 120 volts on a piece of wire, what's the current going to be like?
That's pretty damn high, right?
That's gonna be high.
Right. If I, sorry, can you see me?
Yeah.
Okay. If I put 120 volts across this thing, it's probably going to burn up, right?
Yeah.
If I have a fuse or a breaker on there, it's going to trip that. But if I do this a bunch of times, right, I make it a coil, then I have inductive reactance. It creates a magnetic field that we're using to open and close contacts, right? But it's also going to limit the current. You wondered why you were learning all that crap. Now you know. Are you happy you went through that stuff?
Not really.
Not really. Yeah. But let me think about it this way. If you took Electech 150 this class before you took that class, you'd be a little confused, right?
Completely lost. Yeah.
I'm taking it without the other one.
Yeah, well, you're special,
Ed.
Ed. The amount of pulling or pushing force produced by a solenoid is determined by which one?
Both.
Both of them. The number of turns in a coil, the amount of current through the coil. Solenoid valves are available to control
All of them.
all of them. What kind of solenoid valve blocks flow when the solenoid is de-energized and allows flow when the solenoid is energized?
Normally closed.
For a DC stepper motor, man, there's a lot of questions in these. I didn't realize there's so many.
Yeah. This one was brutal.
Why are you guys not like chewing my rear end for this?
Chapter 5 was worse. It was long as hell.
Yeah.
Chapter was long as shit.
Hey, you got a week to do it.
I know. I'm almost done with 6 right now, and then I'm starting probably 7 tomorrow. So
They'll be moving on to the next class next week.
I know. DC stepper motor amount of rotation is directly proportional to.
This one I didn't. I know it's the frequency of pulses,
The number of
but it's
pulses.
or yeah. The frequency controls the speed, right?
Yes.
Okay.
Which kind of switches are small assemblies designed for mounting on printed circuit boards?
Dip.
Dip switches.
I didn't find that in the book though.
Did anybody?
I didn't either.
The old Google search came through on that
Yep.
one. For me.
I Googled that one too. Well, I didn't really even Google it. I just knew that the proximity wasn't for circuit boards, and limit or the push buttons were not for circuit boards. So I just kind of did a process of elimination, but I didn't find it in the book either.
Does everybody know what a dip switch is?
I sure don't.
I don't think we
No.
have any on your trainer, but you will see them. I'll find some. You've probably all seen them before. There's a good chance. How about, have you guys ever had to program your garage door
Thermostat.
opener?
Yeah.
Not program them.
When they have those little tiny, here, I'll show you a picture. Since we're on the Google. These are dip switches.
Yeah. If you get a multi-function thermostat, one that does more than one, like stage of heat or cool, they usually have dip switches on them, so you know what to set them for.
They're just little tiny switches. I don't know why they don't just call them that. Little tiny switches. I don't even know what does DIP stand for. Extra credit, because I don't know. Dual
the last
inline
one's-
package.
I was wrong.
That was way off.
Samsonite. I knew it started with an S. So. Younger crowd doesn't know what we're talking about, Nick.
I don't think so.
A float switch is used to sense what of the liquid?
Height.
Height. Drum switches are used for starting and
All the above?
all the above? No. Reversing. I would say braking. You could use braking if you were plugging it, you know, by reversing, but the thing is sizing. That's like no. An actuator is any device that converts an electrical signal into
Mechanical.
mechanical movement. All right. Chapter 5.
Oh, God.
DC series motor. Should never be operated without a load. What is an example of a constant horsepower load?
Lathe. Is that how you pronounce that? Lathe, I believe.
A
I
motor
would
with
think so, since they're variable speed. A
What's
fan
that?
would be constant. I would assume that a lathe would be variable speed, so the motor would not be constant.
well, I guess it. I don't know. CNC experts, do they?
Most of them like they're servo motors. So it depends on if it's a lathe. If you're running tailstock, you've got a lot of pressure on it, and what you're cutting. If you're hogging out a lot of material, it is not a constant horsepower load. That's for sure.
Yeah, I don't really like that question because I could see.
I would.
I could see any
Conveyor.
of those being constant horsepower depending on how they're used. Did
Conveyor
anybody get that
is-
one wrong?
I did.
I got it right. It was in the book.
Fan.
Well, if it says lathe in the book, then
Okay. Well, I just made it extra credit just because I just don't like that. It says it in the book, but I just don't like that.
Maybe the 1920 lathes.
A motor with the speed of 1800 RPM and a drive pulley that is 2 inches in diameter is coupled via belt drive to a load pulley that is 4 inches diameter. The speed of the driven load would be
900.
900. Permanent capacitor motor. That one's all of them. Does not require a centrifugal switch. Uses identical run and auxiliary windings. Provides improvement of motor power factor. Squirrel cage rotor consists of.
Single bar short circuited by end rings.
Yeah, and that's how it gets its name, right? Variable AC motor drive delivers
Variable voltage and frequency.
Mm-hmm. I wish I had. That's one thing about these trainers. I wish I could send a drive home with all of you, but we get back into the lab in the fall, and you guys are taking troubleshooting. We can mess around with some drives.
Okay.
Variable AC motor drive is able to operate the motor.
Should be able to do all of them.
Yeah. Voltmeter check of a motor should show voltage within what percent of the motor's nameplate voltage?
%10.
That one's 10%.
I thought it was supposed to be 5.
That's not what this book says.
Okay.
I get mixed up on the percentages too, but an electric motor uses what kind of energy and what kind of energy to produce mechanical energy?
Electric and magnetic.
Yeah. Direct coupling of the motor shaft to the driven load results in
1-to-1
1-to-1
ratio.
1-to-1. NEC 430.22 requires branch circuit conductors supplying a single motor to have an ampacity not less than blank of the motor full load current.
$1.25.
$1.25. NEC article what? Hint, look at the last one. Is the main code source for electric motor installations. Yep, it's 430. On a three-phase motor, the stator windings are arranged to create
A rotating magnetic field.
a rotating magnetic field. We haven't even really talked about motor theory yet. We will. One advantage, DC type motors have over AC types.
Their speed can be easily varied.
What kind of motor has the highest starting torque of all single phase?
Capacitor start, capacitor run.
Very good. There are two basic categories of motors.
AC/DC.
The direction of rotation of a three-phase motor is determined by
Phase sequencing.
the direct rotation on a split-phase motor can be reversed by interchanging the connections to
Either A or B. You can change the run windings or the start windings, but never both.
what's the purpose of a commutator?
To maintain the proper direction of current flow in the armature conductors.
That's correct. A lot of this stuff, like, I don't know, I guess it depends on where you end up at in the field, but when you're dealing with really big motors, it can be more cost effective to have them repaired, right? But 9 times out of 10, if you're working for local industry, you're going to swap them out, and you're going to have somebody in the I'm talking about, like, if a motor goes bad, if you get bad bearings or whatever, it might be cost effective for somebody that uses a lot of motors and an industrial process. To have broken motors, spare parts, and people like us who would go through and diagnose and repair them cheaper than buying a new one. But anymore, especially for smaller motors, less expensive motors, a lot of times they're just going to put a new one in there, right? So
Yeah,
it is
the mo-
important to understand the theory behind what makes them spin. Otherwise, it's like, what the hell are we doing here anyway? You know, like starting motors, but we don't know how they work, you know. But well, in this class, we'll go over the basic motor theory. We need to understand what makes the shaft turn, and then beyond that, to me, it's all about practice with ladder logic. So, all right, that's my spiel. Series type DC motor has which one of those?
Series has high starting torque, right?
High starting torque. The shunt type DC motor is known to have
Great speed regulation.
good speed regulation. Synchronous speed motor of a 2-pole 60 hertz AC motor.
60 times 120 divided by 2. 3,600.
What torque is, how would you define torque?
It's that new dance, right?
Mm-hmm.
Wow.
Torque.
Wow.
Sometimes I just crack myself up. That was good though. New dance.
So that's what we're doing now?
Yeah.
That's what we're doing?
Jokes.
Torque.
What the? Wow.
Oh, you guys are funny.
This point is after 12 hours overnight, everything's funny.
Torque is a rotational force, right?
Yes, sir.
Where did it go? Here it is. Dual voltage 9-lead Y connected 3-phase motor is connected for high voltage. The individual coils of each phase are connected in
Series parallel. Is that right?
series.
Okay.
Just remember, and we're going to go over these together. 9-lead 3-phase motor connections.
The bars.
Just remember, series is high, parallel is low.
Okay.
And I'll explain why when we get to that point. Seems to me like we need to kind of take a break next week a little bit and get into motor theory and those 9-lead motors. So maybe we'll do that Monday. Kind of take a break from the labs. And what kind of torque is produced by a motor functioning at the rated speed and horsepower?
Full load? I don't know.
Full load torque. All right.
So locked rotors where it pulls enough amperage where it won't allow the rotor to do anything, right?
Yeah.
Okay.
Or like you try to start it and it's stuck in between phases, if that makes any sense.
Yeah.
Or if you have too much load on it and it won't start, it's like that's lock rotor torque and it's extremely high current.
Happen a lot with air conditioning. When the start cap goes out, or even the run cap, it'll pull lock rotor amps and just lock up.
It's bad news bears, Nick.
Yeah. It's funny stuff.
That's your homework. We'll plan on taking a quiz on Monday. Over that stuff. So everybody make sure you're here at 9 a.m. on Monday.
I'll show up early.
So I got chapters 6 and 7 due.
Out of here, Goofy. Bye, baby. I love you.
Got those due next Thursday. Would it be helpful to have some more time with chapters 6 and 7? Or is the pace okay for you guys?
It's fine with me, or whatever you guys want.
Are we gonna end up with that extra week at the end like you talked about?
There's a good possibility. It just, I also
Alright.
don't want to like go so fast through the material that like we're coming back to cover things that we did homework on 3 weeks ago, you know. But
Oh, I gotcha.
it is what it is. I don't mind moving through that stuff at a fast pace. I mean, I'm going to go through the lecture stuff regardless of when we do it. It's just whether or not it's all lined up with the homework. So
Yeah.
I'll keep going with this schedule, 2 chapters at the end of every week. And if it gets to be overbearing, then let me know and we'll get through what we have to get through this class. And that'll be the plan. So I guess just be honest with me if you need me to slow down. All right. I'm going to go over this. Okay. So, Wilson, if you were here yesterday or the day before, I did the power circuit for mine with blue wires, and hopefully you can see that on the screen here, but I'll run through it really quick. Line 1 through the power supply, through the fuse. The fuse is right here on the left. That's done. And then I went from plus 24 on the load side of the fuse down to normally open contact here. And that on the print is right here. The other side of the normally open contact goes through our non-existent overload heaters and over to the motor over there. So that's all done. And then the negative side of the motor is just going
Okay,
back.
so on the motor, you went straight from the power? I don't think I did that. Let me see. I don't think that's what I did. Let me see. No, I did not. So I went to a push button. So you went straight from the red lead, from the red power to the motor?
Yeah, well, follow your ladder diagram, Justin. So
No, I'm seeing that, and I seen that when I was looking at it, but I was like, how would the push button start and stop it if it's coming straight from the power?
And
All right.
this one.
look, this is the power circuit, right?
Right.
All we're doing is trying to put 24 volts on this motor and make that thing spin, right?
Right.
So at this point, forget everything down here. At this point, can this motor turn?
Yeah.
No. You don't see a
Why
break in
can't-
that circuit?
Oh, with the negative.
No. You don't see a break in that circuit. Can current flow in this circuit through the motor and back? You see anything open there?
Not really.
What about this? Is this open?
Oh, okay. I got you.
So this motor will not spin until we close this, right? So just think about it, everything down here, all this fancy stuff at the bottom, all that's doing is closing this to turn the motor on, right?
Okay.
So if you don't have the power circuit hooked up right, then none of the other stuff really matters, because that's all we're trying to do is set it up so we can turn that motor on, right? So if you walk this thing through wire by wire, one at a time, like a book, top to bottom, left to right, let's just start with the power supply circuit, and I'll zoom out so you can see the. Okay, start on the left. 120 volt single phase, 60 hertz. That's right here. Right? Justin, you following?
Yeah.
All right. Going into the power supply, so I've got line 1 and neutral. Coming out of the other side, I got a plus and a minus. Just start with the plus. Positive side is going over to the fuse, which is right here. So that's this. The other side of the fuse, right here, is going to our terminal strip. So we can tap into the load side of that fuse anywhere right here. On the load side of the fuse, my blue wire, that's my power circuit, is going down to the motor starter, normally open. Okay? The other side of that normally open contact is going over to the motor. So that's done. The overloads don't exist on your trainer. The other side, the negative lead, is coming right back to the power supply.
Okay.
Is that all making sense?
Yeah, it's starting to.
All right, well, I'm going to move on to the control circuit then. So I got 1, 2 on the right. That makes this a 3. That makes this 4. Over here, these are 4s. 4.
Yep.
These are all 4s.
Yep.
These are 5s. Okay. I'm not going to number mine. I'm just going to do them. I'm going to walk through what's going on in my trainer and follow along. So I highly recommend, and I'm just going to keep telling you this, that you either print these lab diagrams off or you download them from the drive and pull them up in Microsoft Paint like I have. If you have a Microsoft computer, I guarantee you have Paint on there. And then you can mark them up just like I'm doing. But you need to know the numbers. And then if we were in person in the labs, I would have you guys with this piece of paper here, marking off every wire as you put it on. I'm going to do it with a different color so you can see it. But this is how I would do it so I don't lose track. So my wire number 1 going to my stop push button. That's probably going to be there for the rest of the semester because it's already there. So I got 24 volts going over to the stop. Here's my stop. So wire number 1 is done. Done. The other side of my stop, which would be this wire, needs to go to one side of the start. Done. So this is done. This is done. I also needed to go to CR1, normally open contact, which is over here. So on this, whatever that is, needs to go away. I need a wire number 3. Now, where can I pull a wire number 3 from?
The control relay.
Yeah, I know I need to get it. If you're looking at the screen, I know I need to get it from here. And on the relay itself, what's normally open? We were using 9 and 5 last time. So it'd be these two pins, 9 and 5 normally open. So one of those, I need a wire number 3. And let's say I'm going to use it right here because I've got a wire sitting here ready to go. Okay. So I need this to be a wire number 3. Where should I put it? If I'm looking at my ladder diagram, I'm looking right here.
Put it on one of the same rows as the start button that already has a wire to it, if that makes sense.
That will work. So I have this wire number 3 already made up to the start and the stop. Could I put it right here on this 3? Yes. Could I put it right here on this 3? Yes. Right? I just know I need a wire number 3 from right here to be on the same potential as every other wire number 3. Right? I'm going to run this over. Just be easy to put it on the side of that start. So that means that this is done. Everybody following?
I think I seen what you just did. Let me, because I definitely didn't have that right.
That's what I mean when I say take one wire at a time, know where you're going with it. All right, so let's look at wire number 4s. Where do you want to start? Pick a spot. We've got 1, 2, 3, 4, 5, 6 places we need a wire number 4, and they all have to be connected. Well, why don't we just start like a book, top to bottom, left to right, with the other side of the start. Right here.
Okay.
So I know I need to get to
Green light.
the other push button. I know I need to get to the green light, the control relay coil. Let's just look at what I have right next to there already. So I'm right here on my trainer. So I'm on the other side of the start. So this stuff kind of needs to just go away for a second. So I've got my 3s coming into the start, and then down here, a couple rows on the proto board is the other side of my start. I know I need to get a wire number 4 from this side of the start to one side of this yellow push button, right?
Right.
Right here. So that's pretty easy, and it's a very small piece of wire, right? So I'm going to put a little jumper in right there to take care of those 2 places. So that little jumper wire is wire number 4. Can you see it? Probably not.
No, I can't.
Let me zoom in.
Okay, I see what you're doing.
All right, well, look on the screen. You see this little jumper wire from the other side of the start to one side of the push button over here?
Yeah, I see.
What I just did, now look at the print now. I'm gonna mark off what I just did. That and that. So I know what else on this print I still need to get a wire number 4 to, right?
Mhm.
I also need to get one to, my motor starter is also on the proto board. So that'll be a little jumper wire here. Now, can I pull, let's see. Hang on a second. I've got my motor starter normally open, basically the seal in contact, right?
Right.
So that's these 2 wires that I just got hanging here right now. But I need one side of this normally open motor starter contact to be a wire number 4, correct?
Right.
So far, the only wire number 4 I have in there is right there. So I can pull it from either one of these 2 locations. I just need a wire number 4 to get there. Does that make sense?
Yeah.
If I just take this one and go right here, then that one's done. So I, on my print, can do this now. All right. I also need to get up to the green light. So I'm going to back out. And the other 2 locations are on the control relay. All right, so I've got my wire number 4 here and here. So if I come from that same location on the breadboard and go up to my green light, then that wire number 4 will be good. And I already have a wire made up to my green light. I'm just going to stab it into this row. So I've got this done. Now there's 2 other locations that I need to get wire number 4 to. One is the CR1 coil, and the other one is CR1's normally open contact, the other side of where I landed that 3 wire. So the 3 wires here, I need this to be a 4, this little jumper, and I need this to be a 4. Now, you see this jumper is already in there from the coil to the normally open contact. On the print,
Yep.
I'm going to pick a different color here. On the print, that would be a wire that goes from here to basically there. That's a little jumper wire. Does that mean the 4s are done?
No.
Did you already do the normally open contacts for MS1? Yeah.
Yeah,
Okay.
that's done. But I've got this little jumper wire in here. Does that make the 4s done? If I just put a number 4 on there, am I done?
No.
because I have a 4 here, right? I've got a wire on each spot that's labeled 4, but it's not connected to any of these 4s, right? So I need to make sure every 4 gets energized when all the other 4s get energized. You know what I'm saying? I've got this wire in here already made up, and it's just hanging here loose because I haven't made it up to anything yet. But I need to connect those 4s to all the other 4s. So I can come from the green light, I can stab it in right here, which is probably the easiest thing, but I'll just go to the green light to try to make this thing not as messy. And once I do that, then I've connected everything together and all my 4s are done. Am I making sense?
Yeah, I believe so.
So up to the point where I just did, I had everything except for this CR1 contact pulled in, or coil and normally open contact. So what I did was I pulled a wire from the green light over to pin number 13 or whatever that coil is, right? So from the green light to here, and then from there to there. So in doing so, I've got all of the wire number 4s done. So I can cross that one off and I can cross that one off. Moving on to wire number 5. So I've got the other side of my yellow push button right here to the motor starter, normally open contact. Let me zoom in on my breadboard again. Okay, so you see how right now there's nothing made up on the bottom side of this push button?
Right.
So I need to wire from there to normally open push, or normally open MS1 would be this wire right here, right? It's the other side of that normally open contact that we landed our wire number 4. So here's wire number 4. This is wire number 5. And I'm just going to run it up to the bottom side of this push button switch. Doing that, I have this and this done. I also need a wire number. What's that?
So it's kind of blurry.
It's the best I can do. It's zoomed all the way in, so.
I got you.
If you take whatever light that is that's causing a glare, it probably wouldn't be, like if you put your hand over whatever light's shining on it.
Is that better?
Yep.
Yeah. Yep.
And that's fine, but I don't want you guys to just wire yours up exactly how I do it because I just wired it up. Like, you have to understand where everything's at, right? If you don't know why I put a wire in a certain location, you have to tell me, or I'm assuming that you understand it. But I put this little jumper in here from the bottom side of the push button switch to the other side of the normally open motor starter contact. So that is on the print, these two. Okay. I also need a wire number 5 to get to the line side of the resistor. It's right there. The only reason I need a resistor in there is a voltage divider. So I need from one of these two locations, I need to go right there. That's just going to be a small jumper wire.
In that situation, I just ran my resistor from the coil to the bottom side of the push button.
That's fine.
I didn't use
That'll reach. So you went from here with your resistor all the way up to here without putting a little wire in there?
Yeah, because it was close enough.
Yeah, and that's fine. I just do it this way to make it look a little neater, so hopefully you guys can see it okay. But that's this little wire then made up to that resistor on the print, then I can do that. There's only one place left that I need wire number 5, and that's at the red light. So I got these two wire number 5s. I can pull a 5 up to the red light from any of these locations, correct?
Right.
Yes.
Okay. I'm gonna come. Let's see. I'll go all the way down here just to make it so you can see it. So then on my print, now I've got the red light made up and everything's made up. I just got to double check my 2s. The CR1 coil, that's this right here. I've got a black wire going back to the negative on the terminal strip, so that's done. The green light and the red light, we made those up already a long time ago when we did this. Remember, we made little jumpers from there to there, there to there, and then all the way over to here.
Yeah.
So the light, the LED pilot lights, those 2s are already made up. And then the load side of MS1 coil. So this is MS1's coil. The load side would be right here. This little jumper, I brought, on my proto board, I brought a negative from this terminal strip down to this negative rail on the far right. So anytime I need a negative back to the power supply, I can just tap in right here. So this little jumper wire is my 2 from that side of the coil. Now I'm ready to go. So when I turn this thing on, if I press the yellow start button right now, if I press the yellow start button right now, should anything happen?
No.
No, because none of the wire number 4s are energized, right?
Right.
Right here. So until I press the green button and energize all the number 4s, the green button, let's think of that as like control on. So when the green pilot light is on, that means my control is working. So I'll press the green. All right, you can see The green light came on. CR1's energized and it's holding itself. So control's on. Now wire number 4 is energized and I can run the motor. And that would be the yellow push button. So when I push the yellow push button, it'll energize the coil and turn the red light on. And then the MS1 holding contacts, which are right here, will keep it on. You see the red light came on, my motor came on, and it's holding. I hit the stop button and it kills everything. So that's what that lab should look like when you're all done. Green light, green button, yellow light turns the red light on, turns the motor on. The red light stops everything. Okie dokie.
Okay.
Clear as mud.
Pretty easy. As long as you number everything.
Number everything, do one wire at a time, mark it off on your print. Be okay.
All right.
All right. Well, unless there's anything else, you guys have a good weekend. Monday we'll start talking about motor theory and what was the other thing? Oh, 9-lead motors.
Good night, guys.
Good night, Nick.
Have a good day.
You too.
Yeah.
Yeah, I didn't get what you got. I don't know why. When I plug mine in, my green light comes on. I'm not getting a red light. Oh, goodness. Hope I can get what I did wrong. Let's see, from my motor, I ran it from the red to the number 1. From the negative, I ran it to, let's see. I ran it to the negative terminal, That's quite right. My number 1 is ran to the push button. The push button is then ran to the green. Not to the green, to the start button. VR1 and 2. Jumpers. Got that RAM there. Number 4. And down there. That's right there. I don't know what I did wrong. I'm not getting it.
When you plug yours in,
Yeah.
the green light comes on and the motor starts running.
Yes.
Okay. You need to take a look at your wire number 3s. because I'm sure there's a problem there. From one side of the stop,
So I gotta come in from one side of the stop to the push button. And then my other number 3 is coming from the ice cube relay into the same side of the start. Those are my number 3s.
I can't really see what you're doing, but I'd like you to look at my my setup here. Hang on. Are you looking, Justin?
Yeah.
Here's my wire number 1 from red over to one side of the stop.
Yep, I
The
got
other side
that.
of the stop should be wire number 3 going
Right.
to, let's call it the top side of your green push button.
Right, I got that.
Okay, the other side, the same row. So we're still on the top of the green push button.
Right.
That should be going
To the ice cube relay, right?
to the ice cube relay. Pin number pin number 9. So mine's going right here. Is it?
No, I got to go in to pin number 14. I thought we were jumper in 9 and 14.
14 is the coil. Pins 13 and 14 is the coil.
Oh, I got you. Why did I think we were jumpering 9 and why did I think we were jumpering those?
Look at the print. I'm going to use a different color again. Can you see my print?
Yeah, let me get this in here real quick. For some reason, I thought we were jumping pins 9 and 14 together. Where did I get that from? I don't know. I don't remember.
Well, you can think that way. It's fine. I mean, if you remember back that we did this earlier and we jumpered that earlier, but it always goes back to the print, right? Look at the print. Are you looking at my print right now?
Yes, I am.
Wire number 3 right there and right there. Do you see any of those making up to a coil anywhere?
No.
No, they're making up to 2 push buttons and they're making up to normally open contact. So on that ice cube relay, we have a choice, pin 9 or pin 5, and I use 9.
Okay. I got that.
Okay, so then let's look at the other side of the start. So the bottom side of the green button. We're going to start in our wire number 4s, right?
Right.
Mine going to get a little jumper going between the bottom of the green button and the top of the yellow button.
Right.
I got another one from the bottom of the green button up to the green light.
Yep. I got that.
I've got another one from the top of the yellow button to normally open motor starter contact on the left side.
The top of the green.
Top,
top
of
of the
yellow.
yellow.
I'm still on wire number 4, right?
Yeah.
So that's this wire right here.
Okay. All right, I got that. All right, I got that done.
Okay, I've got another one from the green light on the gray terminal strip
All right.
over to pin number 13 on the control relay. That's the coil.
Yep.
You have that?
Yep.
Then I have another jumper from 13 on the control relay coil up to pin number 5.
Yep.
That takes care of all wire number 4s. Wire number 5. So the bottom side of the yellow push button. I've got a little jumper going from the bottom of the yellow button to the resistor, which I think you just had your resistor spanning that whole thing.
Yeah.
I got another one from the bottom side of the yellow push button to the bottom normally open contact on the motor starter relay.
Bottom motor starter relay.
That's this wire right here.
So that's going to the normally open, right?
Yeah, well, there's 2 normally open points on
Right.
that contact. So on mine, the top one, this is a wire number 4. The bottom one is a wire number 5, going from the bottom of the yellow push button down here.
Okay.
That's wire number 5. Then from that same bottom contact, bottom normally open contact on the ice cube relay, going up to the red light.
Okay, I didn't get that part. What you said from the pin 14 on the ice cube.
No, we're not. I'm on the motor starter relay.
Let's see. Got my red. You said the red's going to the relay.
Yeah, so we're on wire number 5, right?
Right.
On the print. So I've got a jumper going from, look on the print, do you see any, this over here, Justin, that's CR1, right?
Right. Yeah.
This is MS1. So on the print, do you see
Right.
any wire number 5s going over to CR1?
No.
No, you should have no wire number 5s on this thing. So I've got one from the bottom of the yellow push button to the resistor. You've just got your resistor spanning that. I've got one from the bottom of the yellow push button down to the bottom normally open contact on that motor starter relay.
Okay.
And then from that same point up to the red light. That's this wire.
I think I got it. Yeah, I think I got that.
And if you've got all
that.
that,
So we don't have, but I don't have nothing coming from pin 14 on the ice cube. That's what I'm confused about. I don't know where that's going.
pin 14 is the negative.
So that's going back to the negative terminal.
Yeah. Right here.
Yeah.
You're talking about this pin right here.
Yeah.
So you should have 2 wires on 13.
Right, I do.
And then you should have a negative wire on 14 going back to here.
Let me try to get this put back into the negative. I think I took it out for something. I don't know why I took it out. I just took it out though. I don't know why I'm not understanding this shit. It's irritating me. Kind of pissing me off.
Not that you're not understanding it. You just need to take it a little slower. And like you're saying, when you say ice cube relay, well, there's 2 ice cube relays there. There's one here. That's your motor starter relay. And then you've got one up there on that black socket. That's your CR1. So keep those things straight. You're just landed wires on different components.
Shit. All right. I think I'm ready to try to see what this thing can do, I hope.
Fire it up.
Hey, damn it. God fucking damn it. How?
Hey, Justin.
Yeah.
Now I'm thinking that maybe your power circuit's not exactly right. So do me a favor and at your motor, you got 2 wires coming off your motor.
Yeah.
You should have one black one that goes back to the black terminal strip, right?
Yeah.
Where is your red one going?
Hooked into the number 1.
Number 1.
Up at the fuse. Up at the fuse.
Right here?
Yeah.
Well, of course, that motor's going to start spinning as soon as you plug it in.
Well, I talked to you about that, was it yesterday? And you said it needed to hook up there because it had to power everything. You said it wouldn't start unless we had the motor starter in with it. That's how I understood it. That's how I understood it. It needed to be connected up there. So it needs to be connected into the circuit down below.
Look at the print, okay? Remember we
Right.
talked this morning about how this motor starter contact needs to be closed for that thing to run?
Right.
So where is MS1? Where's motor starter 1 on your board?
It's all the way at the bottom.
Right here. right? So for mine,
Yeah.
my power circuit is the blue one. So I'm going from the red on the motor down to one side of this contact. And on the other side of the contact, then I'm going back up to the red terminal strip. So what I'm saying is that motor won't spin until this thing closes, right? And on the print, that's what this MS1 normally open contact is.
So that means I need to switch this to, let me think here. So this needs to go into the MS1 and it needs to come, would this be a 4 or a 5?
This, like my blue wires here, because I can't see what you're
Okay, hold on. I'm looking, hold on. So this would need to come in on a 5. My motor starter, my red, needs to be a 5.
No, your power circuit does not get wired. We're up here at the top.
Right,
This is a power circuit.
okay.
It sounds like you went from fuse 1 right here, so that ends up being all these, straight over to the motor
Yeah,
instead of going through your motor starter.
okay, so.
On your print, MS1 contact right here, that needs to close before the motor turns on. That's what this thing's job is to turn the motor on. And that's what this is right here.
So, okay, I think, so it goes to the normally closed contact. No, it needs to go to the normally open contact.
Correct.
So then my red light needs to go to the common pin.
No, forget about the red light. Do you have anything on the right side over here on yours?
Yeah, I just put in my motor over there now.
Okay. That should be the only thing on the right side. That's your power circuit.
Right, okay. All right, I got that. I put it on the normally closed contact. Or normally open, I'm sorry, normally open.
Right. So that when this coil gets energized, it will turn the motor on.
Okay. I got that now. All right. So I got that. And then on my number 5. So number 5 also needs to go to. I'm gonna have to start over because I'm fucked up right now.
It's not a bad idea, and there's nothing wrong with it. And you got this video will be on YouTube within an hour, so you can walk back through it as many times as you need to. The thing that I see with you, Justin, is that you need to keep straight what's your motor starter, what's your control relay, what the different components are, and then if you just follow the print and do one point at a time, I think you'll be fine. I think you're underestimating yourself. You're just getting kind of overwhelmed when you put it all together and it doesn't work. But if you plug that thing in, it should never start unless your motor starter tells the motor to turn. You know what I mean?
Yeah. So I'm gonna just wait until I'm gonna start all the way over. Fuck it. Yeah, once you post this, I'll go ahead and restart it.
Okay.
All right, appreciate it.
All right, man. It'll take a little bit of time for it has to do its thing, but it should be on the YouTube thing within an hour, I would say.
All right,
All right, man. Have a good day.
you too.